Welcome back to Red Blue Labs. Today I'm going to be doing a Wireshark video and I'm going to be showing you what my first step always is when I get a brand new Wireshark capture that I'm supposed to analyze. Every single time is open up endpoints in the statistics dropdown and then take a look at stuff. I'm going to be demonstrating endpoints on two unique captures to show how we can use that tool to come to a conclusion about something that's strange happening in the capture. So what I've got on the screen right now is a very basic Wireshark user interface. This is the default one. It's nothing fancy. We've got nothing really cool up inside in the button. It's kind of gross. Nothing really particularly useful. That's why I recommend building out your own profile. You can watch this video for some high-level instructions on how to do a profile. The particular capture that I have on the screen now is actually one that I've used in a different video where I used it to identify bot traffic. You can check out that video right here. I'm going to pretend that I've never seen this capture before. I want to dig into some of the statistics windows that are particularly useful. So up on the top left of our screen here, we can actually see that we've got a bunch of items that we can select from. And we are going to dig into statistics here. Whenever I get a capture, the first thing I like to do is identify the private network. Who is in there and talking out onto the internet, okay? Or talking in locally. That would be very useful as well. Identifying network scans and whatnot. Let's go and dig into the first one that I like to do. I've said this in videos before. I'm doing it again because I really think it's important. So I would go to statistics and then go to endpoints. We've got the endpoints open, and what it's going to be helping us here to figure out is who's talking at this moment. And in this whole capture, what are the IP addresses that are in play? Only two machines here. That's fine. We've got MAC address for one machine, another MAC address for another machine. Let's take a look at the IP addresses here. And we've got a Class C, two Class C IP addresses, and we've also got a public IP address here that we could actually determine where that's coming from. Let's talk a little bit more about some of the things that we can see inside of the endpoints window here. Map. Let's see if we can do an open in browser. When we click on the map, it's actually showing me where is this IP address coming from. If I were to zoom out, we'll see where this is. Paris. Oh, interesting. So that IP address is coming from France. And that's pretty cool. And that's something that we can connect to from the endpoints window. Let's look at copy. We could copy this data into a CSV, YAML, or JSON. All of these would be useful for doing as a Python script. I'm going to choose CSV just to see what it gets. So copy that. Awesome. That gives us the specific data on that endpoint, which is kind of amazing. We've got our IP address from that output, and even over here we can see some geo stuff related to that IP address that is inside of endpoints. Awesome. Let's quickly jump into another capture and use endpoints to identify and learn about some of the private network that's present inside of that capture. So how we do that is we are going to open up a capture that we've already saved. Go to File, Open, and then locate the file that you want to put into Wireshark. Okay, I've uploaded a file called secret, and we're going to fly on over to statistics and go on down to endpoints. Now there's a little bit more happening inside of this particular capture, and I am going to be looking particularly at the Ethernet, which is interesting to me, and IPv4. Now I can see right away that there's a very unique relationship between Ethernet and IPv4, right? I've got 12 Ethernets, 12 MAC addresses in here, and then I've got 139 IP addresses, which is pretty weird. Okay, so let's dig into the IP side of things to try to identify like what's going on. Right away, I've got a lot of weird IP addresses. I got a 1.192, I got a 2.189. You know what? Why don't we copy all this data and take a quick look to see if there's any like country things, because these could be like from different countries. That would be interesting. Copy CSV, copy that. And if we look at the data that's spit out, we can see we've got a lot of particular locations. I got Japan, I got Sweden, Mexico, United States, Japan, Canada, Australia, United States, like Malaysia's in there, Colombia. Kind of interesting, kind of confusing as well. Why are there so many IP addresses from these different locations? What's going on? Knowing that there's a lot of obscure traffic from other countries potentially, why don't we organize our IP addresses to figure out who is in the private network and what is the range here? Now, if you're looking at the screen, you can see on the grayish purple here that it's a 1.75. So I'm kind of looking for a class C over here. But I'm gonna sort the address column here to see if we can make it a little bit easier to see. Okay, click it again. I'd like to go lower high. So now I'm going to scroll through all 139 of these things to land on what I know to be class A or a class C. And we'll go all the way down to class C here. And we have some weird ones here. 117, 192, but whatever here, 192, 168, 1.66. Those are particularly interesting to me because they tell me that there are some class C assets that are part of this particular capture. Look at the bytes that are being sent by all of these weird things. 54 bytes, 54 bytes, 54 bytes. That's too regular, right? But as soon as we get down to 1.66 here, we got 1 kilobyte. We've got from 68 here, 80 bytes. This seems to be like more of a normal traffic type of situation. Of these ones that I believe are normal packets, I would look at the ones that are sending the most. Okay, so in this particular case, I would zero in on 1.75. Okay, so let's right click on that and apply it as a filter. We learned something very interesting here. In our packets, we have a whole bunch. This is 88% of the total traffic. Where does 1.75 show up? If we look at our filter that was created, IP address, that would be wherever IP address of 192.168.1.75 shows up in the source or the destination. And in this particular case, I don't see. We could check. Let's modify our filter here. See if we see anything in the source. Goes green. We're good to go. Hit enter. Now we see the moment in time when the 175 talks out to the network. And in this particular case, nothing really of value. But what we do have that's of value, let's modify our filter again to destination. We're going to hit enter here. And now everything that has 1.75 in the destination part of the header is showing up. And that's where we get that 84%. It's a lot. So what would I do at this point? I would go down and dig into the details window. All right, we're going to click on packet number 64 here, and we're going to select it and open this up a bit here. and look at some of the similarities that we have. Like, obviously the IP addresses here are different. Okay, that's fine. Uh, but is there anything else that stays the same? Remember when we looked at endpoints, we could see that there were only 12 MAC addresses and a ton of IP addresses. That's leading me to sort of believe that potentially there's a machine on the network that is spoofing IP addresses and send them all off to 1.75. Let's take a look. This is the details window, extremely useful. All of the information you want about a packet is going to be located inside of here. If we cycle through these, let's look for things that are staying the same. Okay, we can see the source IP address changing, but there is something that's not changing. Okay, and it is in fact the source Ethernet. Very important. All of these packets here are being sent from the same machine, but the IP address is changing, so it's being spoofed. Extra challenge mode here. If all of these are spoofed, then does that machine have, in this massive list of IP addresses, is one of these IP addresses the real one? Could I locate that machine and figure things out? The answer is yes, we can. We could do it with a simple filter. So I know that the source is staying the same. I'd like to know which private IP address is the real one. I open up the frame here, the Ethernet here, and we're going to click on this and then apply the filter. So let's look. This is all of the Ethernets from the source. Okay, so here's some evidence that all of these packets are being generated by the same machine. They just have different IP addresses. If we come on over here, something important happens. ARP traffic. Wonderful protocol, can reveal a tremendous amount of information. Let's take a look at the whole capture here. If we look over at the info part of that ARP traffic there, it says who has 1.75, remember that's our target, tell 192.168.1.77. That reveals something very important to us. We know that these are the same Ethernet from the same attacking machine, and if I wanted to zero in on 1.77, we're going to learn that that's the real IP address out of this whole mess of garbage packets. Awesome. So what we learned here is that all of the stuff that we've discovered started from the endpoints window. We were able to determine various, who's the private network, is there any anomalies between the Ethernet and the IP address, where should we start digging? And that's where I start. I always start at endpoints. All right, thanks for watching. I got a couple other videos on the screen that I think you're going to enjoy. Go ahead, give them a watch, and we'll talk soon. Bye.